Hello, Danielowski here from y2mate.com. In this video, we will learn what is Hall effect and how Hall effect sensors work. The Hall effect is the most common method of measuring magnetic field, and the Hall effect sensors are very popular and have many contemporary applications. For example, they can be found in vehicles as wheel speed sensors, as well as crankshaft or camshaft position sensors. Also, they are often used as switches, MEMS compasses, proximity sensors, and so on. Now we will go through some of these sensors and see how they work, but first let's explain what is the Hall effect. Here's the experiment that explains the Hall effect. If we have a thin conductive plate as illustrated and we set current to flow through it, the charge carriers would flow in a straight line from one to the other side of the plate. Now, if we bring some magnetic field near the plate, we would disturb the straight flow of the charge carriers due to a force called Lorentz force. In such a case, the electrons would deflect to one side of the plate and the positive poles to the other side of the plate. This means if we put a meter now between these two sides, we will get some voltage which can be measured. So, the effect of getting a measurable voltage, as we explained above, is called the Hall effect, after Edwin Hall, who discovered it in 1879. The basic Hall element of the Hall effect magnetic sensors mostly provides very small voltage of only few microvolts per Gauss, so therefore these devices are usually manufactured with built-in high-gain amplifiers. There are two types of Hall effect sensors, one providing analog and the other digital output. The analog sensor is composed of a voltage regulator, a Hall element and an amplifier. From the circuit schematic, we can see that the output of the sensor is analog and proportional to the Hall element output or the magnetic field strength. These type of sensors are suitable and used for measuring proximity because of their continuous linear output. On the other hand, the digital output sensor provides just two output states, either on or off. These type of sensors have an additional element, as illustrated in the circuit schematic. That's the Schmitt trigger, which provides hysteresis or two different threshold levels, so the output is either high or low. For more details how the Schmitt trigger works, you can check my particular tutorial for that. An example of this type of sensor is the Hall effect switch. They are often used as limit switches, for example in 3D printers and CNC machines, as well as for detection and positioning in industrial automation systems. Another contemporary applications of the Hall effect sensors are measuring wheel speed or RPM, as well as determining position of crankshaft or camshaft in engine systems. These sensors are composed of a Hall element and a permanent magnet, which are placed near a tooth disc attached on the rotating shaft. The gap between the sensor and the teeth of the disc is very small, so each time a tooth passes near the sensor, it changes the surrounding magnetic field, which will cause the output of the sensor to go either high or low. So, the output of the sensor is a square wave signal which can be easily used for calculating the RPM of the rotating shaft. Thanks for watching, and for more tutorials visit my official website y2mate.com.